Hello everyone, today we will go through Kubernetes architecture interview questions. Kubernetes, often abbreviated as K8s, has become the go-to platform for orchestrating containerized applications. Kubernetes is an open-source platform designed to automate deploying, scaling, and operating containerized applications. It automates the deployment, scaling, and management of applications in a containerized environment. Let's discuss master node components. API server acts as the front end for the Kubernetes control plane, managing all API requests. etcd, a distributed key-value store which holds cluster state and configuration data. Kube-Scheduler, determine where to run newly created pod based on resource utilization. Controller manager messages various controllers that maintain cluster state. Let's discuss worker node components. Kube-Late ensures containers are running on each pods as defined. Kube-Proxy handles network traffic and communication between pods. Container runtime run containers, commonly Docker or containerd. Let's go through Kubernetes interview questions and answers. Question 1. What is Kubernetes? Kubernetes is an open-source container orchestration platform that helps automate the management, scaling, and deployment of containerized applications. Question 2. What are containers? Containers encapsulate an application along with its dependencies, making them portable and consistent across environments. Question 3. What problem does Kubernetes solve? Kubernetes handles the complexity of managing containers at scale by providing capabilities such as load balancing, scaling, service discovery, and resource management. Question 4. What is container orchestration, and why is it important? Container orchestration automates the deployment, scaling, and management of containerized applications, simplifying infrastructure management. Question 5. Explain the basic components of Kubernetes architecture. Kubernetes is an open-source container orchestration platform that helps automate the management, scaling, and deployment of containerized applications. Question 6. What is a pod in Kubernetes? A pod is the smallest deployable unit in Kubernetes, consisting of one or more containers that share the same network and storage namespace. Question 7. How do Kubernetes services work? Services in Kubernetes are an abstraction that defines a logical set of pods and a policy to access them. Question 8. What is the difference between Kubectl and the Kubernetes API server? Kubectl is the command line tool for interacting with the Kubernetes cluster, while the API server is the central component that exposes the Kubernetes API and serves as the entry point to the cluster. Question 9. What is the role of the Kubernetes scheduler? Answer. It assigns pods to nodes by evaluating factors like resource requirements and policy constraints. The Kubernetes scheduler plays a crucial role in deciding where your workloads run in a cluster. It watches for newly created pods that have no node assigned and then selects the best node for them. It factors in resource requirements, constraints, and affinity-anti-affinity specifications, balancing the load across your cluster. It's like the ultimate matchmaker for your applications and computing resources. Question 10. How does the API server interact with etcd? Answer. The API server uses etcd to store the current state of objects and updates it when changes occur. The API server is the heart of Kubernetes, acting as the communication hub for the whole system. It interacts with etcd, the key-value store, by reading and writing all cluster data to it. Whenever you make a change via Kubectl or any other client, the API server processes that request and updates the state in etcd. Essentially, etcd holds the desired state of your cluster, and the API server ensures that the actual state matches it. Question 11. What is the significance of Kube-Proxy in Kubernetes networking? Answer. Kube-Proxy manages the network rules and ensures pods can communicate with each other and external services. Kube-Proxy is essential for Kubernetes networking as it maintains network rules on nodes. It ensures that traffic is properly routed and load balanced across your cluster. By managing IP tables and user space proxies, Kube-Proxy makes sure that your services are accessible and that communication between different components flows smoothly. Essentially, It acts as a bridge, connecting your applications and their services. Question 12. Explain the role of the controller manager. The controller manager is like the conductor of an orchestra in Kubernetes. It runs multiple controller loops to ensure the actual state of the cluster matches the desired state, as defined in the etcd. These controllers include Node controller, watches for newly added nodes, ensures that they're up and running, and handles node failures. Replication controller, ensures the desired number of pod replicas are running at any given time. Endpoints controller, manages the endpoints objects, which help in service discovery. Service account and token controllers, create default accounts and manage API access tokens. All these controllers continuously monitor the cluster's state, making adjustments as needed to keep things running smoothly. Kubernetes wouldn't function without this key player keeping the symphony in sync. Question 13. How does Kubernetes handle networking between pods? Answer. Kubernetes ensures that every pod can communicate with every other pod, regardless of the node they're on. This is achieved using a pod network overlay. Kubernetes uses a flat network model, so each pod gets its own unique IP address. This simplifies communication because all pods can talk to each other directly without NAT, network address translation. Each node in your cluster runs a Container Network Interface (CNI) plugin that implements the Kubernetes networking model. These CNIs ensure that the network fabric spans across all nodes, allowing pods to reach each other seamlessly. You can think of it as Kubernetes creating a large, dynamic network of interconnected islands, pods, with bridges, CNIs, ensuring there's no isolated island. Question 14. What is a service in Kubernetes, and what are the different types of services? Answer. A service is an abstraction that provides a stable IP and DNS for accessing pods. A service in Kubernetes is an abstraction that defines a logical set of pods and a policy to access them. It provides a stable endpoint, an IP address and port, for clients to connect to, even as the pods behind the service change. Service types include cluster IP, node port, external name and load balancer. Question 15. What is a service in Kubernetes, and what are the different types of services? Answer. A service is an abstraction that provides a stable IP and DNS for accessing pods. A service in Kubernetes is an abstraction that defines a logical set of pods and a policy to access them. It provides a stable endpoint, an IP address and port, for clients to connect to, even as the pods behind the service change. Service types include cluster IP, node port, external name and load balancer. Question 16. How does a node port service work? Answer. A node port service in Kubernetes allows you to expose a service on a static port on each node's IP address. Essentially, it maps a port on all the nodes in your cluster to your service. Here's how it works. When you create a node port service, Kubernetes allocates a port from a range, default is 30,000 to 32,767. It then sets up routing rules so that any request sent to node IP, node port, gets forwarded to the underlying pods of the service. This means you can access your service from outside the cluster by hitting any node's IP at the assigned port. This setup is useful for exposing services on-premises or where you don't have a cloud load balancer. Question 17. How does a node port service work? Answer. A node port service in Kubernetes allows you to expose a service on a static port on each node's IP address. Essentially, it maps a port on all the nodes in your cluster to your service. Here's how it works. When you create a node port service, Kubernetes allocates a port from a range, default is 30,000 to 32,767. It then sets up routing rules so that any request sent to node IP, node port, gets forwarded to the underlying pods of the service. This means you can access your service from outside the cluster by hitting any node's IP at the assigned port. This setup is useful for exposing services on-premises or where you don't have a cloud load balancer. Question 18. Explain network policies in Kubernetes. Answer. Network policies in Kubernetes are like firewalls for your pods. They control the communication between different pods and network endpoints, defining what is allowed and what isn't. You can specify these rules using YAML configurations. These policies can define rules based on IP address ranges, namespace selectors, and label selectors, giving you fine-grained control over network traffic. It's crucial for enhancing security and isolating sensitive workloads. Question 19. What are the differences between ingress and a service? Answer. An ingress and a service in Kubernetes are both ways to manage traffic, but they serve different purposes and work on different levels. Service. A service exposes a set of pods internally or externally. It gives your pods a stable endpoint even if they are moved or scaled. There are different types of services: cluster IP, node port, load balancer, and external name. It's primarily for managing traffic within your cluster or exposing it in a basic way to the outside. Ingress. An ingress is more advanced. It's a collection of rules that allow inbound connections to reach your cluster services. It can provide load balancing, SSL termination, and name-based virtual hosting. It works with an ingress controller to manage traffic, meaning it can route to different services based on HTTP paths or hosts. Question 20. What is the difference between a volume and a persistent volume in Kubernetes? Answer. Volumes in Kubernetes are used for data storage, but they come in different flavors with distinct purposes. Volume. Ephemeral storage tied to the life cycle of a pod. When the pod is deleted, the data in the volume is also lost. Examples include empty dir, host path, config map, and secret. Persistent volume, PV, provides persistent storage independent of the pod life cycle. Lives beyond the life of individual pods and can be reused. Managed by the Kubernetes cluster and can be dynamically provisioned based on storage needs. Requires a persistent volume claim, PVC, from the pod to bind the storage. Question 21. How do persistent volume claims work? Answer. A persistent volume claim, PVC, in Kubernetes acts like a request for storage. Here's how it works. Request. You create a PVC in your cluster, specifying the amount of storage and the type of storage you need, example SSD, HDD. Binding. Kubernetes looks for a matching persistent volume, PV, that meets the criteria specified in the PVC. If it finds one, it binds the PVC to that PV. Mounting. Once bound, your pod can use the PVC to access the persistent storage. You just reference the PVC in your pod's configuration. Persistence. The data stored using a PVC remains intact even if the pod is deleted or recreated, ensuring data durability. PVCs provide a way to request and use persistent storage in a way that's decoupled from the underlying infrastructure. Question 22. What is a storage class, and why is it important? Answer. A storage class in Kubernetes defines the way storage is dynamically provisioned. It abstracts the details of storage provisioners, such as cloud providers or local storage solutions, and specifies parameters like the type of disk, SSD, HDD, replication policies, and more. Why is it important? Because it allows you to automate storage management based on defined policies. Decouple storage management from application deployment. Standardize storage across different environments. In essence, storage classes make managing storage scalable and straightforward, aligning with Kubernetes' overarching principle of declarative configurations. Question 23. Can you explain how stateful sets differ from deployments regarding storage? Answer. Stateful sets and deployments serve different purposes, especially when it comes to storage. Deployments focus on stateless applications. Pods are interchangeable, meaning any pod can replace another. Suitable for services like web servers where each instance is identical. Storage is typically ephemeral unless explicitly attached to persistent volumes. Stateful sets designed for stateful applications. Pods are unique and not interchangeable, each having a stable, unique identifier. Maintains a consistent network identity and persistent storage. Each pod can have its own persistent volume claim, PVC, ensuring data is retained across restarts. In essence, use deployments for scaling stateless applications and stateful sets when you need stable, persistent storage and unique identities for pods. Question 24. What is role-based access control, RBAC, in Kubernetes, and how does it work? Answer. Role-based access control, RBAC, in Kubernetes is a method for regulating who can access the cluster and what actions they can perform. Here's how it works. Roles and cluster roles. Define sets of permissions. Roles are namespace scoped, while cluster roles are cluster-wide. Role bindings and cluster role bindings attach roles to users or groups. Role bindings work within a specific namespace, while cluster role bindings apply cluster-wide. RBAC ensures that users and services can only perform actions they're authorized for, enhancing security and control. Setting up RBAC policies can help you manage access efficiently and securely in your Kubernetes cluster. Question 25. How does Kubernetes handle sensitive data? Answer. Kubernetes handles sensitive data with the help of secrets. Secrets are designed to store and manage sensitive information like passwords, tokens, and keys. Unlike config maps, which are meant for configuration data, secrets are stored securely in etcd and can be accessed by pods through environment variables or mounted as files. This ensures that sensitive data is managed separately and securely. Always a good practice to use secrets to keep your data safe. Question 26. Explain pod security policies. Answer. Pod security policies, PSPs, in Kubernetes are a set of controls used to enforce security standards for pod creation and updates. They define the conditions that a pod must meet to be accepted into the system, such as restricting the use of privileged containers, limiting the use of host namespaces, and controlling the use of volume types. PSPs help ensure that your pods are deployed in a secure manner, preventing potential security vulnerabilities from being introduced into your cluster. They act as gatekeepers, enforcing best practices and compliance requirements. However, Kubernetes is deprecating PSPs in favor of more flexible alternatives like the Pod Security Admission Controller and third-party security solutions. Moving forward, you'll need to adapt your security practices to align with these new methods. Question 27. What are service accounts in Kubernetes? Answer. Service accounts in Kubernetes provide identities for processes running in pods. Unlike user accounts, which are for humans, service accounts are for system components to interact with the API server. They help manage access and permissions, ensuring that applications have the right level of access without exposing sensitive credentials. Service accounts streamline the management of authentication and authorization for workloads, making your cluster more secure and easier to manage. Question 28. What are service accounts in Kubernetes? Answer. Service accounts in Kubernetes provide identities for processes running in pods. Unlike user accounts, which are for humans, service accounts are for system components to interact with the API server. They help manage access and permissions, ensuring that applications have the right level of access without exposing sensitive credentials. Service accounts streamline the management of authentication and authorization for workloads, making your cluster more secure and easier to manage. Question 29. How does the horizontal pod autoscaler work? Answer. The horizontal pod autoscaler, HPA, in Kubernetes automatically adjusts the number of pod replicas based on observed CPU memory usage or other custom metrics. It checks the current load against defined thresholds and scales the pod count up or down to maintain optimal performance. This ensures your application can handle varying traffic loads efficiently without manual intervention. A great way to ensure your apps stay responsive and resource efficient. Question 30. What is the role of the cluster autoscaler? Answer. The cluster autoscaler in Kubernetes is like your cluster's resource manager. It automatically adjusts the number of nodes in your cluster based on the resource demands of your workloads. If your pods can't be scheduled due to insufficient resources, the cluster autoscaler adds more nodes. Conversely, if there are underutilized nodes, it removes them to save costs. It's all about ensuring optimal resource allocation and efficiency. Question 31. How would you ensure high availability in Kubernetes? Answer. High availability in Kubernetes involves multiple layers to ensure your applications and services are resilient and always accessible. Here's how you can achieve that. Multi-node cluster. Spread your nodes across different availability zones or regions. This prevents a single point of failure. Replica sets and deployments. Use replica sets to ensure multiple instances of your pods are running. This way, if one pod fails, others can take over. Load balancers and ingress. Deploy load balancers to distribute traffic across multiple nodes and replicas, ensuring no single component gets overwhelmed. Persistent storage. Use persistent volumes that replicate data across multiple zones to avoid data loss if a node fails. Health checks. Implement liveness and readiness probes to monitor pod health. This ensures failed pods are restarted automatically. Cluster autoscaler. Enable cluster autoscaler to adjust the number of nodes based on demand, maintaining performance during traffic spikes. Disaster recovery. Regularly backup your etcd data and have a disaster recovery plan in place to restore your cluster quickly. Question 32. Explain the difference between horizontal and vertical pod autoscaling. Answer. Horizontal pod autoscaling, HPA, adjusts the number of pod replicas based on CPU, memory usage, or custom metrics. Ensures your application scales out, more replicas, or scales in, fewer replicas, according to the load. Vertical pod autoscaling, VPA, adjusts the resource requests limits of a single pod based on observed usage patterns. Ensures each pod gets the right amount of resources, CPU, memory, it needs, preventing over-under provisioning. HPA scales the number of pods, while VPA adjusts the resources allocated to each pod. Combined, they keep your app scalable and efficient. Question 33. What are the common tools for monitoring Kubernetes? Answer. There are several popular tools for monitoring Kubernetes, each offering different features and capabilities. 1. Prometheus, a powerful open-source monitoring tool that collects and analyzes metrics from your Kubernetes cluster. 2. Grafana, often used alongside Prometheus, Grafana provides a visual interface for analyzing and visualizing metrics. Kubernetes Dashboard, a web-based UI for managing and monitoring your Kubernetes cluster. 3. Datadog, a comprehensive monitoring solution that provides deep visibility into your Kubernetes environment. New Relic offers detailed performance monitoring and insights for Kubernetes workloads. Jaeger specializes in distributed tracing, helping you understand the flow of requests through your services. Elastic Stack, ELK combines Elasticsearch, Logstash, and Kibana for powerful log analysis and visualization. Dynatrace provides full-stack monitoring, including Kubernetes, with advanced AI capabilities for root cause analysis. Question 34. How do you collect logs from a Kubernetes cluster? Answer. Collecting logs from a Kubernetes cluster can be done in several ways to keep tabs on what's happening inside your cluster. Kubectl logs command. For quick access, use kubectl logs podname. This command fetches the logs from a specific pod. Fluented, a popular logging agent that can collect, process, and forward logs to various destinations like Elasticsearch or a cloud service. Elasticsearch, Fluented, Kibana, EFK, Stack. Fluented collects the logs, Elasticsearch stores them, and Kibana provides a visual interface for querying and analyzing the logs. Prometheus and Grafana, while primarily used for metrics, they can also handle logs with appropriate configuration. Loki and Grafana. Loki is a log aggregation system designed to work with Grafana, allowing you to correlate logs and metrics. Cloud provider solutions. If you are using a managed Kubernetes service like GKE, UX, or EKS, they offer integrated logging solutions that capture and store logs automatically. Question 35. What is the Kubernetes metrics server? Answer. The Kubernetes metrics server is a component used for collecting resource usage data, like CPU and memory, from your cluster. It gathers these metrics from the Kubelet on each node and makes them accessible through the Kubernetes API. This is crucial for autoscaling and monitoring, as it provides the data needed for decisions on scaling pods and optimizing resource allocation. Question 36. how would you troubleshoot a pod stuck in pending state? Answer: troubleshooting a pod stuck in the pending state in Kubernetes can be a bit tricky, but here are some steps you can follow to diagnose and resolve the issue. Check pod events. Use the Kube-Scheduler describe pod name command to get detailed information about the pod, including any events that might indicate why it's stuck in the pending state. Check resource availability. Ensure that your cluster has enough resources, CPU, memory, etc., to schedule the pod. Check quotas and limits. Verify that your namespace or cluster has enough quotas and limits to accommodate the pod. Analyze scheduler logs. Check the scheduler logs for any errors or warnings that might provide more insight into why the pod is stuck. Restart the pod. Sometimes, simply deleting and recreating the pod can resolve the issue. Question 37. How would you resolve networking issues in Kubernetes? Answer: use Kube-Scheduler to inspect network policies, ensure that kubeproxy is running properly, and review the underlying CNI plugin configuration. Resolving networking issues in Kubernetes involves several steps and tools to diagnose and fix problems. Here are some common approaches. Check network policies. Ensure that your network policies are correctly configured and not blocking traffic between pods. Verify DNS configuration. Kubernetes relies on DNS for service discovery. Use Kube-Scheduler commands. Utilize Kube-Scheduler commands like Kube-Scheduler get pods, Kube-Scheduler describe pod, and Kube-Scheduler executive to inspect pod status and logs. Monitor network traffic. Tools like TCP-dump, Wireshark, and Kube-Scheduler can help monitor and analyze network traffic to pinpoint issues. Review logs. Check logs from the Kube-Late, kubeproxy, and your CNI plugin for any error messages or warnings related to networking. Update and patch. Ensure that your Kubernetes cluster and all components, like CNI plugins, are up to date with the latest patches and updates. Check node and pod network interfaces. Ensure that network interfaces on nodes and pods are correctly configured and not experiencing any conflicts. Thank you for watching this video. Do not forget to subscribe our channel.